Okay, so welcome everybody to our ENSA class for Tuesday the 23rd. Real quickly, what I'll show you is something that I just sent out in MailChimp, so you should have gotten it if you're supported by us. And it is a quick email discussing what is being called the new, where'd it go? Where'd it go? It just showed up here and now it's gone. It's the new experience is what it is. For whatever reason, it didn't go. That's under because I'm in the wrong place. But it is the new experience, and it is only dealing with at this point, these 8 classes. So if you're teaching any of these in the fall, Get Connecting, Introduction to Packet Tracer, NDG, Linux Unhatched, Intro to Cybersecurity, Cybersecurity Essentials, Intro to IoT, Networking Essentials, or Entrepreneurship, and only these 8. So nobody freak out at this point yet. But there was actually an IPD event today, and there's one actually going on right now at 3 o'clock. I did the 8 o'clock one this morning, but there's one going on at 3 Eastern time. But what is happening is this: they're transitioning to a new, they call it the new experience, new course experience. I'll go ahead and tell you, it's Moodle on the back end. They won't say it. It's kind of making me angry. They've got this politician statement that they put in at the thing saying, oh, it's a new thing we're developing, blah, blah. It's Moodle. But it's Moodle on the back end. It looks just like the existing experience. And it's very, very similar to the existing experience. But notice it's only for these, what they call the exploratory courses. The reason this is of importance to everybody who's an instructor is this. Many of you probably create your classes during the middle of the summer and have them ready for yourself in the fall. If you do that, these courses that you create before July 31st are going to end on October 30th. Now, why they did that, I have no idea, folks. That is just a dumb move on their part. What Cisco should have done is any class that was created doesn't end until December. I'm not Cisco. They evidently just don't understand academia at all, which blows my mind since this program's only 20-something years old. But the thing is, if you have created any of the 8 courses listed that I'm showing here and have them ready to use for your school in the fall, this also goes for any of the self-enroll that you've set up. So I've got an entire set of self-enroll classes. For instance, if I go to stanley.edu, and I've set up all of these under my IT Academy, what I call my free classes. All of these are self-enroll classes. So anybody that's enrolled using these links is enrolling in a class that's using the old experience. So in other words, it's still under Canvas, not under the new system they're developing using Moodle as the back end. I'm going to have to change all of these on the 31st of July so that it points to a new course, because otherwise all of these end on, unfortunately, October 30th, 2020. So if you're going to teach any of these in the fall, do not create them until August 1st. All right. And again, you can look at you can watch these things here. Hopefully they'll post a recording link that we can actually give out to y'all that shows it. But for the most part, it looks exactly the same. The grade book's a little different, and there's some differences. I'll be up front with you, but it's the basic navigation is the same. You're not going to have a lot of problems there, but just be aware that there will be 2 different course experiences for you depending upon what you're managing. Now for the students, now I will tell you this, once you get into the content hasn't changed. So the content interface looks exactly the same. This is only for the back-end NetAcad portion that you were seeing as an instructor. And for the most part, it looks exactly the same. Just want to make you aware of that. So you can look, and there's a little video here that they show. And you can, you can see it's pretty much the same, very similar. And there's
of course, from the NetAcad.com, I'm learning or I'm teaching.
So here's the old look, here's the new look. So, and again, no, they can't hide the fact that it's Moodle, but it is, and they won't admit it, which aggravates me to death. But just be aware, they're calling the legacy as our Canvas. This is what it's going to look like. This is only for these 8 classes right now. Is it going to happen for the other ones? That's what they're probably wanting to do. I don't know. This is being recorded, so I won't give my opinion as to what I think is going to happen. But we'll see. We'll see what happens. But just be aware, if you're using any of these courses, you will have a slightly different look in the class versus what you've got right now. And you need to wait after the 31st of July to create your fall classes. Any questions on that before we change gears and move over? All right. So you can go in here, like I said, if you go under into NetAcad and you go to your news and events for instructors, and you look up the platform updates, the next evolution is coming, click here, and you'll be able to actually look at the product team, talk about the new course. So it goes through and gives you information, pretty short little thing on what it looks like and what it is. So again, I don't think it's that big a deal in terms of for these 8 courses. Once it rolls out for other courses, I think it will be interesting to see what happens. I think it is smart to roll it out in these 8 courses first, so that we can kind of test it on the non-core, what I call the core courses, just to ensure there's no major issues with the platform. I'm predicting it's not going to be a hell of a load, but that's just me. So, any questions on that before we go back into our ENSA? All righty, go ahead. Somebody was about to say something. Good gracious, I had all this graded this morning. So somebody turned in some stuff today. So, couple things I do want to mention to you when we're looking at grades on, especially packet tracers with the ACLs. I want you to be aware, especially for your students, and you know this, packet tracer is very literal. Packet tracer, if it asks for it to be named a certain thing and you don't name it that, you won't get points. If it asks you to use the keyword and use the port, it won't give you points. So be aware that sometimes you inside of NetAcad, or not NetAcad, packet tracer can build the ACL correctly and it will still not give you the points. So just be aware, and on one example, I found the ACL was wrong, the instructor had turned in, but many times your students can turn in an ACL and functionally it works fine and it would meet the requirement anywhere else, but packet tracer won't give them points for it because it doesn't do exactly what packet tracer asked for. So just be aware of that. That's an issue that can come up. Any questions again on ACLs before we move up to NAT, which I did post the NAT lecture for you last week. If we look at our assignments, let's just go to assignments here. You will see that the assignments due this week are the NAT packet tracers and the NAT labs. Okay, so there's a basic 682. You're figuring that for IPv4. So those are due this Sunday, and you got things a little bit easier. So, and also chapter 7, which is pretty much just a read lab and do some basic WAN concept PKs. So those 2 are due 6 and 7. 7's not really anything that's all that hard. It's more of a theory chapter than anything else. You also see that 7, 8, and 9, after 7, 8, and 9 really don't even have labs all that much. Actually, there's no labs or packet tracers for 8 and 9. So let's jump into course here and jump over to our NAT chapter. Now, I did in my discussion of NAT, I used some different naming than what they talk about in this particular course or in this particular section. They talked about dynamic NAT and PAT only. I talked a little bit about the concept of dynamic NAT and then dynamic NAT with overload, and then PAT, which port address translation is technically dynamic NAT with overloading to a single IP address. Inside of NAT, it is just translating from those private addresses to public addresses. The most confusing thing that I always have trouble with is this right here, the inside global and local versus outside global and local. Just remember that anything that is inside is the address of the device which is being translated. Okay, so the inside local address is the usually typically RFC 1918 address. The inside global address is that inside host that's being translated to a public address. And then outside local address is the outside IP address or the destination address. And typically the outside local and outside global are the same in most implementations of NAT. One of the reasons you have this is because it is possible to actually NAT between two RFC 1918, and it's even possible to NAT between two networks that use the same internal addresses. So that's kind of where they pulled some of this from. For most of us, I wish you could just pretty much go inside, outside, with inside local being that private address, inside global being the public address that's NATed to. And literally the device just keeps a table. It just keeps a table of what the inside local to the inside global address is, and that's what it's being NATed to. And if it's a one-to-one NAT, that could either be NAT using dynamic NAT with a pool that does a one-to-one mapping, or it could be static NAT, which is what you use for your internal web servers or your web servers on a DMZ, so that they're accessible via a public address. Hold on one second, folks. Actually, I'll have to call them back. I'll just have to let that ring. Any questions on the basics of NAT? Any questions on why we need NAT? Okay, none of those. That's pretty easy. Again, static NAT, basically, if we're going to try to go to an internal host that's using a private address, you're going to have some way for that host to be resolved to a public address. And then you will also more than likely have that IP address being resolved to a fully qualified domain name. And that's something I wish they mentioned inside of here instead of just doing SSH to 209.165.200.226. I wish they put SSH to www.acme.com and then had that being resolved to 209.165.200.226, which is what you will do in the real world. If you need a one-to-one outside to inside translation, you would have to have a single public address for all your inside private addresses. Not something we normally do. Typically, it's only for our devices that need to have external access to themselves on the public internet. We can also do, and that's something they mentioned later, not a whole lot about, but you can also do port forwarding. So in other words, it would be possible. Let's imagine that R2's IP address on the outside was 209.165.200.226. You can set up R2 to forward anything that comes in TCP 22 and have that forwarded inside to 192.168.10.10. And you notice they're missing a dot in here, so they need to put a period in here unless they're trying to do some really funky IP addresses. So that would be what's called port forwarding, and you'd still be using the external single IP address, but it would be able to forward into an internal host. And that's what you're doing at home when you've only got one public address and you're forwarding into, say, your Xbox and your PlayStation and those types of things, or your PC, if you happen to be forwarding into your PC. So here's what I call just dynamic NAT. And so you create a pool and you'll do a one-to-one NAT mapping until you run out of addresses in the pool. And once you run out of those addresses, nothing else on the inside will be able to get out using NAT. I'll give you a strange thing that happened to us a couple years ago. We did not have dynamic NAT with just a single pool. We used dynamic NAT with overload, which would be, so you've got this pool of addresses. You'd have a one-to-one mapping all the way up to 229, and then on 230, that address would be used for port address translation. So everything else past the first four would be getting NATed to the .230. Well, we had our greatest enrollment ever. Never had so many people on campus. And we were having a problem where hosts literally in the same room, one could get to the internet and the other one couldn't. You'd reboot one and then the other one would get to the internet and the other one wouldn't. And it was so random and weird. We got to looking, and what we had done is our NAT pool, the address that had been assigned to be used as the PAT address in the pool, was actually already being used in a static NAT assignment. So it could not be used for that PAT, for the dynamic NAT with overload. And so the end result was, as soon as we run out of addresses in the pool, which we had in that case back then, I think we had like 80 or maybe more, maybe 150 addresses in the pool. As soon as we got to the 150 first address, nobody could get out. The host couldn't get out to the internet. And then when the timer would clear out the NAT table, or someone would turn a machine off and it would release the NAT table entry, then someone else could get on. So it was an interesting little problem to try to figure out. If we had not had that final address, in this case on the screen you see here, the 230 would be the final address. If it is not assigned to a static NAT and it was correctly configured, if you do it with an overload, you would be able to just have pretty much as many internal IP addresses as you want being converted to that 230. I think there is an upper limit. I think it's in the range of 16,000 to a single IP address. I think it's in that range. Don't quote me on that. I think it's actually even higher than that. But I think that's one of the ones I'd read at one point, 16,000 plus. Okay. And so port address translation just says, instead of doing a one-to-one mapping, let's take a setup to where we can have multiple inside hosts use the same outside IP address and keep up with both the source IP and the source port and the destination IP and the destination port. You can do that because you're pulling a random source port and you're going to a destination, okay? And if two hosts happen to pull the same source port, you're just going to increment it by one in your table. And so you just go up by one on the outside, and then it really doesn't matter that they're internally using the same source port because they've got a different internal private IP address. So inside of your table, as long as you're able in that NAT table to keep things unique, you are able to use more than one inside address being mapped to an external IP address. Now, again, advantages. Well, here's the thing: we wouldn't have the internet if we didn't have NAT. We've been out of IPv4 addresses for a very long time. We would all be using IPv6. The negative is that when you get looking at NAT and PAT, if you do a NAT, it is a one-to-one mapping unless you do overload. And so you still have to have enough internal or external IP addresses to do the internal. The problem with both of these is the fact that you lose that end-to-end traceability. The NAT translation table will eventually go away. And so you have to be careful that it's hard to track back to an individual host who may be doing something on your network, external to your network. So again, here we have just using port numbers. If it is not if you don't have a layer 4 segment, you can use the query ID, and that will be used to identify it. There are other ways of doing it too. You can use protocol number, depending on what you're using there. But for the most part, things use TCP or UDP. You're going to use your source and destination ports. But otherwise, just like with ICMP, you can use the query ID. Talk a little bit about advantages and disadvantages. Not going to spend a lot of time there. Static NAT, we've got an outside client trying to get to our web server on our DMZ, preferably, not the inside network. Again, I wish I would say something like DMZ network. But this is a static NAT translation, where if you go to this IP address, you would get routed over to R2, then R2 would translate it into the private address of 192.168.10.254. This we would still have to put on R2 access control list that allowed web traffic to come in if we were setting up security, but that would be different than the NAT translation. So just because something's set up to where it can go through doesn't mean it's going to be NATed to be able to go through. We also would still need to set up our inside and outside, even though if you do a static. So IPNAT inside source static, inside outside. That's my little sing-song, IPNAT inside source static, inside outside. And then you have to set what port is on the outside and what port is on the inside. One place people get into a lot of trouble is, imagine that this internal interface right here It's a serial interface in this case, but imagine it's an Ethernet, and it is configured with router on a stick to support multi-VLAN traffic. You have to make sure that you put on every one of those sub-interfaces IP NAT inside if you want that inside interface to be able to be NATed. So be aware of that. That's something that's not really talked a great deal about in here, but it's something to be aware of. Show IP NAT trans as your friend. That will show you static translations. Okay, you can see it here. And this would show you when there's actual traffic going on. So you've got your inside local. So that's my private IP address. There's the public IP address that's being translated to. And here's the host it's connected to using TCP. All right. So I think NAT's very easy. It's not a whole lot of, not much to it, honestly. So here's dynamic NAT. We set up a pool. The only difference between dynamic NAT and dynamic NAT with overload is the fact that you put on this step right here, overload. So step 1, define your pool. So this gives us a pool of addresses, 226 to 240. Step 2, set your NAT ACL, and you'll notice it's just a standard ACL that says what can or should be NATed. Step 3, IP NAT inside source list 1 pool, NAT pool 1. So it says anything that matches list 1, translate it using this pool. You must make sure that the case is correct. And then set your inside-outside interfaces. You'd be amazed the number of times people get to step 3 and they forget step 4 and 5, myself included. So if you think you have NAT set up and you do a show IP NAT trans and nothing's in there, make sure you've set your inside-outside. If you have set inside-outside, the next thing I usually check is I check my access control list to see if my ACL is correct. Okay. So again, show IP NAT trans. You can see the translations here. You can see them going on so that it's being translated to each individual IP address in the pool. You can clear IP NAT trans star, which clears all translations. And you can do statistics that will show you the, again, a little more detailed information. And so here's Pat using a single address, IP NAT inside source list 1 interface as 010 overload. So this says anything matching access list 1, pat it to whatever IP address is already on 0010. You still have to set your inside outside. Now they call this pat using address pool. I call this dynamic NAT with overload. But you create your pool just like you would before. Create your access list just like before, and you relate the pool to the access list and use the keyword overload. This will then map a one-to-one mapping until you get to the final address in the pool, and then it will pat everything to that final address in the pool. Okay. Show IP NAT trans. You can see now, as soon as you see the ports, you're doing port address translation, especially when you're seeing that you're being translated to the same public address. And folks, that's NAT. I mean, it's really simple. It's really easy. It's not even a concept that really exists inside of IPv6 so much. It is, however, a fundamental thing on the internet. So I do think it's very important that you spend time on it with your students, that you make sure they are able to configure static NAT, dynamic NAT, and PAT, all 3 of those, and understand how they work, because they're gonna, everywhere they work, NAT's gonna be implemented in some way or fashion. Okay. Any questions? None? All right.
I'm good.
Go ahead.
No, I'm good.
Okay. I'm only going to spend a few minutes on the WAN chapter because honestly, this is just more stuff you can read. I will tell you one of the things that I find very humorous is we talk about high-speed internet access. And how many of you have gigabit internet access at home? Not many of us, right? I mean, there's some of you, I'm sure. But the minimum network interface card you can buy right now is a gig network interface card. And so we talk about high-speed internet, and yet the internets are, you know, really not high speed. Our LANs are much faster than any of our WAN connectivity 99% of the time. Now, will that change? Of course. I'm hoping for Starlink to make satellite fast, but this is all about looking at what WANs are, wide area networks, looking at different types of topologies and different types of services that are available. I always tickle people because I call this full mesh. That's the satanic topology. But point-to-point, hub and spoke, dual homes where you've got multiple different hubs. And a lot of times when we talk about dual home, we talk about a network being connected to 2 different ISPs. Just make sure on the upper end that your ISP is not all using the same backend behind that ISP. That's happened before. So you think you got 2 different ISPs and they actually rely on a 3rd ISP behind them. And when it goes down, you lose all your connectivity. So carrier connections, looking at your single carrier versus dual carrier or dual home. A lot of times if we're running dual home, this is where we get into running BGP, because we have to be able to control how traffic goes out and how, more importantly, how it returns to our networks. I think the big thing looking at WANs is that in the OSI model, they're layer 1, layer 2. That's where they're at. So we're looking, you know, as far as data link protocols, frame relay, ATM used to be one, Metro Ethernet, HDLC, obviously less used, PPP, definitely less used, broadband, which is cable and DSL, and then physical is how it actually goes out on the wire. So when we look at WAN services, for the most part, we're looking at layer 1, layer 2 protocols. And I'm pretty much just going to let you go through the rest of this on your own, folks, because it's not, I don't think there's really that much in here that's earth-shattering. If you've had a basic networking class, in fact, a lot of it's kind of a little bit of a rewind on what's been in IT. And I will say one of the things to mention in this wireless internet-based, but the satellite internet, again, there's some very interesting things going on in satellite internet, especially when they're looking at SpaceX is hoping to have less than 20 millisecond delay in their setup. So I think there's a launch tomorrow of another 60 satellites. So it's just kind of interesting that where they'll be at fairly soon. They're going to be able to offer access to the northern hemisphere of the United States and Canada, and then their goal is to eventually make it to where it can be throughout the United States completely. And they're looking at speeds much faster than this 5 to 25 megabits per second. So, which is someone who gets 11 megabits per second at their house, that would be very nice. So, all right, any questions? Any questions on that? Any questions on WAN concepts? And we're going to get into VPNs and quality of service, 2 chapters there, and then move on. So I think we're doing pretty good in terms of timing. I'm going to stop the recording.